Okay, so this is the last part of the review of chapter 15, section 2. So my warm-up question for you today is, what is always true before and after making a dilution? Well, what's always true is the moles of solute before the dilution equal the moles of solute after the dilution. In other words, the only thing we're really changing is the volume the moles are in. So they started out in a small volume at a high concentration, and they end up in a large volume at a lower concentration. But the total number of moles is the same before and after the dilution. Now, labs keep stock solutions with high molarities. It's just a very common thing. And also, usually when you buy solutions, they have high molarities. To do an experiment, you oftentimes need to make lower concentrations of solution from these high concentration stock solutions. This process is called dilution, where the solvent, it's usually water, is added to a portion of the stock solution to make a new lower concentration solution of a known volume that we need to use for our experiment. Now, key observation for dilutions. As I said in the warm-up, moles of solute after dilution have to equal the moles of solute before dilution. Moles solute after equals moles solute before. So when we're making a solution, molarity decreases, volume increases, moles remain the same. So if you were to look at a very simple formula, the M equals N over L formula, the moles in the denominator of that formula remain the same. Volume increases, molarity decreases. Makes sense. Now, the key formula we use to solve dilution problems is here. M1V1 equals M2V2. This is written out with a little bit more detail, but it's a very simple formula. Now, if we have a question, a student is asked to make 1.5 liters of a 0.200 molar solution of sodium chloride from a 5.0 molar sodium chloride stock solution. Now the question is, how much of the stock solution do we need for this? And how much water must be added to this portion of the stock solution to make our final volume of 1.5 liters? So the first thing we want to do after we set up our little equation is define the variables. Okay, and you can see that the initial molarity is the molarity of the stock solution, that's 5 molar. V1 is the amount of this that we need to use. That's what we're going to solve for. We don't know what that is yet. M2 is the final molarity, and V2 is the final volume. So once we set those all up, we plug them into the formula. So you can see here is M1, here's V1, here's V2, here's M2. So we're going to need to solve for V1. V1 is 1.5 times 0.2, and that product is divided by 5. That's how we would solve for V1. And when we do that, we see that we need 0.060 liters of our 5 molar sodium chloride. So that's one of our answers. All right, that tells us how much of the stock we need. It doesn't tell us the other question, or answer to the other question, which is how much water do we add? Well, what we usually do is we assume the volumes are additive. So think about it. If we need 1.5 liters final volume, and we already have 0.06 liters, all we have to do is subtract the final from the amount of stock that we're adding, and we'll come up with the volume of the water that we have to add to the 60 milliliters, the 0.06 liters, in order to make our final volume of 1.5 liters.